So it may be that there's a new class of particle that has no interest in interacting with the kinds of particles we're made of. But we're not in the regime to find those particles. This kind of particle accelerator at Geneva will be testing energy levels that may reveal this class of particles, supersymmetric particles, that's what they're called. And they would have the properties of the dark matter, what we're calling dark matter in the universe. And then we'd have the solution to that, and we go on to the next problem. But dark matter has been a mystery for 80 years, a cosmic mystery. Right. But that's one of many. And string theorists are trying to eke out something to help them out. And I still think they need even higher energies than what are now planned.
Okay, we have time for one more question, and several people have asked questions around this general area. Is what you see the most interesting and proximate questions that are being worked on by astrophysicists and cosmologists in today's research?
Oh, there's no question about it. If you were to rank the problems, the unknowns, you want to start with the ones that make you feel most stupid, okay? So, for example, we know the universe is expanding. That was discovered by Hubble, the man, back in the 1920s. And, okay, we can understand that gravity, it should be slowing down, though, because the gravity operates to bring it back. Observations in the 1990s showed that we're not only expanding, we're accelerating. There's some mysterious pressure in the universe operating opposite that of gravity. Turns out this opposite gravity, this inverse term, it's kind of anti-gravity, though has science 5 baggage that I don't want to bring into this. It's more a pressure opposite that of gravity. There's actually a term in Einstein's equations that allows this. So the physics doesn't have trouble. The Einstein physics doesn't have trouble with this term. It's trying to understand what's causing it. We have no way to understand how this can be. So we call it the dark energy problem. Not that we know that we don't know what it is. It's just a placeholder. The dark energy problem. I put that number one list. There are missions being planned at NASA right now to try to further probe the properties of the dark energy. Next is the dark matter problem. That's been with us for 80 years. We still don't know what it is. It's less of a big problem as dark energy. Dark energy is like 75% of everything in the universe is dark energy. 85% of the rest of what's in the universe is dark matter. 4% is us. Electrons, protons, neutrons, and light. Everywhere in the universe, that adds up to 4% of everything that's out there. So we don't know what 96% of the universe is. We can measure it. We know where it is. We know how it operates. We don't know what it is. And so these are top questions. Next, and I'll end with the last one, the next one is simply understanding how to go from inanimate chemistry to animate chemistry. Complex chemistry such that you will have a collection of molecules that after 3 billion years can pose the question, how did I come to be this complex chemistry of molecules? And it's been said that the atom is the universe's way of posing questions about itself, because the atoms become molecules, become life. And so those are the most profound in the search for life. Find another life form, then compare it. Imagine what you'd learn. Maybe it's made of DNA. That'd be kind of interesting. Maybe DNA is inevitable. Or maybe nature's cleverer than that and comes up with a host of ways to do it. You go to Mars, find out it's DNA. By the way, we learned that there are bacteria that stow away on rocks that can be thrust off of planets after getting hit by an asteroid, move through interplanetary space and land on other objects. Bacteria that are hardy, that can be freeze-dried and reconstituted and radiation and frozen and squeezed. We got those on Earth. Suppose Mars, which we know was once wet, had that whole flora and fauna. And now they're all gone, but maybe Mars got hit and one of these rocks with bacteria on it came to Earth, seeding Earth with life. It's called panspermia. It's a real idea with real physics to support the idea. If that's the case, that means all of us are descendants of Martians. Which has got to be better than Venereals. Yeah, okay. Thank you for your time.